Hi everybody. For those of you that I haven't met yet, my name is Jeff Burchett. I'm one of the co-founders here at Bigleaf Networks. And one of the most common things I talk about day in and day out at Bigleaf is how the heck does Bigleaf work? I have customers asking me questions, I have partners asking me questions, I have industry people asking me questions, and we figured it'd be a lot easier to just make one video to answer all the questions for everybody. So let's take a stab at this thing and let's see if we can get into how Bigleaf works. Before we start about Bigleaf and how it works, let's talk about what the heck Bigleaf is. Bigleaf's not just a router. We're not competing with a box that you would buy one time. Bigleaf is a service. We like to call it a routing platform, if you will. We have a router that goes at your prem. We have a lot more that goes with that, and we wrap a nice support package around that to make it very easy for you as the customer to leverage multiple internet connections as part of your cloud strategy. When you look at the cloud and the significance of the cloud and how important your internet connection is to the cloud, you start to realize that using two internet connections is a pretty good strategy. And what we found is while buying two internet connections is very easy, using two internet connections is not. And that's what we set out to do with Bigleaf. So the first thing that should stand out about Bigleaf is our architecture. We look quite a bit different than that of some old router. We do have a router. It does sit at your location, but like I said, Bigleaf is more than that. We pair that router with these network-based server clusters, and they work in tandem to facilitate the Bigleaf service. We connect these two components together with these tunnels. And think of these tunnels like a modified VPN. We made some changes to them to better meet the needs of internet optimization as opposed to secure site-to-site transport. And these tunnels are significant because not only do they connect the two components together, but they traverse your entire internet connection. They pass through your carrier's last mile, middle mile, core router, peering point, out of the public internet and back around to us. So we have the most complete view and the most control over your internet connectivity. The first big feature in the Bigleaf product set is same IP failover. You've heard of same IP failover before, I'm sure, via something like BGP. But Bigleaf wanted to make same IP failover easier and faster and more effective in this real-time cloud environment. So what we do is a little bit different. When you sign up for Bigleaf services, we issue you a new block of public IP addresses. And what's different about Bigleaf public IP addresses is where they live. These Bigleaf IP addresses are issued via our core clusters. These core clusters, when you think about them, are far more significant than that of a single router at a customer location. They're placed in strategic data centers throughout the country. They consist of fully redundant hardware. They have redundant transit circuits in and out of them. And they also have data center to data center redundancy as well. So if something were to happen to a given data center, a customer's traffic would move to another data center in roughly 5 seconds. And with same IP failover, we can be completely application agnostic. We don't do some things for some services, but not other things for other services. Basically, anything that you would point at a public IP address, you now point at a Bigleaf public IP address. And that traffic, as you can see from the diagram here, would point at that core cluster. And that core cluster at that point becomes a gateway. Your traffic passes through that gateway and then into the tunnels that we determine are the best fit for that type of traffic. And when we move your traffic back and forth between these tunnels, we do them without changing the IP address because the IP address itself lives in the core cluster. And that functionality is at the core of many of the other features that we use. The next big feature is our intelligent load balancing. Our thoughts on intelligent load balancing is kind of based on this idea that while we love customers to use multiple internet connections, we don't want them to feel like they're buying a backup internet connection. We hate the idea of buying something you hope to never use. Rather, our attitude towards it is if you've got these multiple connections, A, let's use them, and B, let's use them for what they're best for. And we facilitate that via our intelligent load balancing. So the way that intelligent load balancing works is predominantly via those tunnels. So we pass monitoring data, roughly 10 custom packets per second over each one of these tunnels, so across your different internet connections. And we use these monitoring packets to measure all sorts of different performance metrics, including uptime, packet loss, latency, jitter, and throughput. And we're taking all these measurements in real time, so we know the exact state of your circuit. For example, on a throughput measurement, if you have a best effort circuit, something like a 50 by 10 coax connection, well, it may not always be 50 by 10. It may be 3 o'clock in the afternoon and the kids come home from school and somebody's running BitTorrent and there's oversubscription and you're only getting 33 by 6. Well, with our monitoring platform, we know that information and we adapt to that. And while our intelligent load balancing is measuring the performance of your circuits, it's also identifying your different traffic types. So if you as the customer have a VoIP phone call and a Microsoft patch going on at the exact same time, we would identify those different traffic types via both our cluster and our on-site router. And we would use all the performance metrics from those different circuits to determine which circuit is best for which type of traffic. So for example, if you've got a 5x5 Ethernet over copper connection from a telephone company and a 50x10 coax connection from a cable company, and you're running a VoIP phone call and you're downloading a Microsoft patch, our platform would look at those performance metrics and would most likely put your VoIP phone call on the Ethernet over copper connection, because we know that VoIP is very performance sensitive. It's very packet loss, latency, jitter sensitive. Versus that Microsoft patch probably isn't that performance sensitive, but needs a lot of throughput, needs to get moved in a hurry, and the coax connection is perfect for that. The cool part about that decision making is that's not a static decision. Plenty of routers can do that via a static rule. We're adapting in real time to those circuit conditions. So if we are transporting that VoIP call over that Ethernet over copper connection, but halfway through that VoIP phone call, something happens to that connection. Let's say packet loss jumps up to 8%. Well, your standard router really wouldn't do anything about that. But in our environment, we would. We would see that packet loss. We would know that it's negatively affecting your VoIP traffic. And in less than 4 seconds, we'd actually move that VoIP phone call off of that Ethernet over copper connection and over onto the coax connection, intelligently moving traffic around based on application requirement and circuit performance. And if you remember our same IP failover story, when we moved that traffic from one circuit to the other, we did it without changing the IP address. So the call was uninterrupted. The session was never broken, whether it be VoIP, virtual desktop, VPN, SaaS, you name it. Anything pointed at that IP address is going to move across those circuits based on the performance of those circuits without interrupting the session, without losing the phone call. The next big feature we bring to the table is our dynamic QoS. And as much as we love the cloud and we love SaaS, dynamic QoS and voice over IP and virtual desktop drive a significant amount of business for us today. As many of you know, voice over IP services love MPLS environments because you can tag your voice packet with a QoS header, and the carrier will look for that header and will honor that header through their MPLS network, and your voice is always prioritized as it passes over their backbone or through that connection. Unfortunately, MPLS is expensive, and carriers don't have the same QoS story around their internet backbone. For a lot of them, they treat all traffic the same, and if it gets buffered, so be it. It's not their problem. And that's the point when your VoIP phone calls start to get a little choppy, and we start to question the value of something like virtual desktop. At Bigleaf, we wanted to fix that. We wanted to be able to provide quality of service over those commodity internet connections. And here's how we do it. If you remember, one of the performance metrics we're monitoring is throughput. We know the throughput of your circuits in real time, and we know that across the entire path. So if your traffic is being buffered somewhere across the carrier's network, we would know that. We'd know where it's being buffered and the rate at which it's being buffered down to. And we would know how that would negatively affect your VoIP. And while we can't force the carrier to do anything with their buffering, we can react to it, and we can react to it in real time. So if that best effort circuit was supposed to be 50x10 but is being buffered down to 33x6, with our dynamic QoS, we would see that, and because we own both ends of that connection, both of the ingress and the egress via our tunnels, we would simply constrict that tunnel down to the point that we're not letting any more traffic onto that circuit than that circuit can support in an unbuffered state. So carrier gives you 33x6, we respond with 30x5. We honor your QoS tags at both ends of our network, and we assure that those voice packets are getting prioritized through our tunnel and are not going over that carrier network at a rate the carrier network can't support. And lastly, the most important feature of everything we do is the plug-and-play manner in which we provision services. It's our goal to drop transparently into your environment. We're not advocating that you have to replace your firewall or buy really expensive internet connections or work with your VoIP provider or your virtual desktop provider or your SaaS provider to change the way they're routing services. Instead, we want to sit seamlessly and transparently in your network. When you sign up for Bigleaf services, you will provide us some information about your circuits. We're going to want to know who the carrier is, what kind of circuit it is, some IP address information. But that's it. We take that information, we use that to pre-configure the router, and we drop ship you a pre-configured router. There is no on-site technician. There is no installation window in which you have to call into us between 3 p.m. and 3:05 p.m. and if you don't, you're going to lose your install. If you can plug in a couple of RJ45s and you can change an IP address on a firewall, you are now a certified Bigleaf installer. It is that easy. It's meant to be plug and play. It's meant to be very simple to use for you as the end user, for your partner, or for your IT consultant. And if you still need our help, we are here 24/7/365 on the phone and via email to help you with that in any way we can. We do know that at the end of the day, our service has to stand out above everything. So with that, guys, I want to say thanks for taking a couple minutes to learn how Bigleaf works. This is meant as a very high-level overview. We're going to provide some additional videos that dive deeper into these specific features over the coming weeks and months. But beyond that, we'd love to sit and chat with you about it. So feel free to reach out to us directly. You can find our contact info at www.bigleaf.net. Or more importantly, reach out to someone in our Bigleaf partner network, probably the person that sent you this video in the first place. They've already been trained up on what we do and how we do it and would love to talk to you more. So thanks, guys. We hope to work with you soon.